So hi everyone, and welcome to my game development workshop. We're going to be using PyGame today. For this workshop, I'm expecting you to know some Python basics. I'm not going to cover the basic concepts of Python. I'm expecting you to know already about variables, lists, for and while loops, and if else statements. We are going to go over functions and classes because we will use a lot of that in PyGame, but that's pretty much it. If anyone has any question during the workshop, please don't hesitate to ask in the workshop channel. I do have it open on the side, so I can answer any question. All right, so without any further ado, let's just start directly into it. And please do tell me if you can't read what I'm writing. But we'll start with some Python, simple Python. No PyGame for now. So we'll start by explaining functions and classes for those of you who maybe don't know about it. We're just going to put everyone on the same level. So a function is basically a bunch of code that instead of writing it multiple times and changing maybe one or two variables, simply having the variables set as parameters of the function and then calling the function with different parameters every time. So I'll write a simple function and maybe you'll understand that better. So in order to call a function, you simply use the def, so define method. And after that, you name your function. So the first function that I'm going to write is simply addition. So this function is going to take two parameters, a and b. And that's how you write it. So between parentheses. And it is going to return a plus b. So it's very simple. It takes two parameters and returns the sum. So we can see this. For example, if I did addition 1, 2, now we see that the code does run, but there is nothing that's outputted. It's because this now has the value of a plus b, so 3, but we didn't print it. So if we wanted to see the actual result, we'd simply print, and there you go. We see the result. We can do a bunch of stuff with functions. For example, if we wanted to do the addition of the sum of this and, for example, 3 and 4, and then we can print that, and you'll see that it does work. Yeah, there you go. So it adds 1 and 2, then it adds 3 and 4, then 1 plus 2 plus 3 plus 4 gives a total sum of 10. So functions are very useful. You can use them for a bunch of stuff. But in PyGame, what we're going to use mostly are classes. So for classes, let me just comment this out so it doesn't output it every time. So classes is basically one object that will have multiple functions inside of it. And all of these functions will be based off that object. So let me give you an example. The classic example for a class is a calculator. So by defining a class, I simply give the name, and then I define it as an object. So the first function that usually goes into a class is the initializing function. So to define the initializing function, it is simply def and then 2 underscores init for initialize and another 2 underscores. And we can use the keyword self. Now, what self does is it basically says that any variable that I define in one function inside of this object, any variable that we define inside of any function of this object will be inherent to the object and not only to that function. Okay, I see some questions. So do we need to download Sublime to create the game? Okay, so for the game, you will need you probably need some kind of text editor. You could probably do it in any text editor, as long as if you run import PyGame, it does work anyways. You can also just watch if you just want to see me make the game, but if you want to code along, you'll need some kind of environment to code in. I don't know if that answers your question. Do we have to? So okay. Well, you don't have to download Sublime Text. It's so if you want to code along, yeah. So you could just do it. I sent some links in the workshop channel yesterday. Oh yeah, you could. So yeah, you can use Sublime. Yep. Higming, can you give some examples of environments? You mean like coding environments? So okay, yeah. So basically, you you're using Wing IDE. I don't I I don't really know the different IDEs. I mostly use Sublime, but I mean, if you can run PyGame, then you should be fine with it. I don't know if anyone can answer that question, but it should work. I mean, if you can write code in it, then usually you should be fine. How do you run code? Oh, yeah, to run your code, you simply do Control B, or I think there's probably some kind of selection signed. Yeah, you can just run the code with Control B. Yikes! Wait, so do you need to download Python using that link? And yeah, you need to download Python, and you need to install PyGame as well. I sent all that yesterday, so if you already know about classes and functions, then you can use the time just to make sure you have everything for the actual game. All right, so I'll keep going. Basically, the initializing function is where you're going to say if you need different parameters for the function. So let's say we need, again, A and B spaces. You can define the variables. So I'm just going to write this for now, and then I'll explain it to you. Self.b is equal to b. So basically what we're doing is we're doing a version of the variable that is proper to the entire class, and we're setting it equal to the parameter that we're getting when the class is called. And we're doing the same thing for both parameters. So it might be clearer when I actually write the other functions. So in calculator, let's say we have a sum function. So we need to write self, so it goes and grabs all of those inherent variables, and this will simply return self.a plus self.b. The spaces aren't necessary, it's just to make it look a little better. And then let's have a multiplication, let's just call it mult. Also with self, and it will return self.a times self.b. So this is fairly simple. Let me show you how you actually use a class. So for a class, you need to define an object. So let's say C is a calculator object using the two numbers 3 and 4. So 3 being the A parameters and 4 being B parameter. You'll notice that you don't need to actually write anything for the self. Self does not require anything. These are the parameters that we need to fill in. So if I run this, again, nothing outputs because we actually need, for example, to print c.sum. Now it goes into the C object, which is a calculator, and it finds the sum function. So if we run this, you can see that it actually does 3 plus 4. And if we wanted to output the multiplication as well, now we see 7 and 12. So 3 plus 4 is 7, and 3 times 4 is 12. This type of, these classes are very useful in a game because you can have multiple objects with slightly different things. So for example, let me give you a very concrete example in game development. If you're making an enemy that will have different functions, you can create multiple iterations of that enemy, but for example, set a different position on the screen for each one of them so that they have the same properties, but they're not all at the exact same spot. Now, one great way to use a class is by using a list and a for loop. So if we create a list called calcs for calculators, and then we append two different calculator objects. So calcs.append. Append is simply a function that will add an item between the parentheses to the list. I started to write, okay, chicken potato load, you actually need to save the file as a Python file. So you'll notice that there's a .py at the end. of the file name. After you save the file, the color should be coming up. Because when you don't save it as anything, it's actually all going to be white. It's just a text file. I hope that was your problem. So let me append two calculator objects. So let's do the 3 and 4 again, but let's also add a 2 and 5, just so we have a bit of variety. And now what we can actually do is do for C calculator in the calcs list. We can do C print C.sum, no problem, C.sum and C.mult. And now you'll see that it actually does it for all of the functions inside the calcs, all of the objects inside the calcs list. So the sum is 3 plus 4, 2 plus 5 is the same sum, so 7. And then the product is 3 times 4, 12, and 2 times 5, 10, yeah. So you don't actually need to write a variable name for each one of your objects. You can just add them all to a list and then loop through that list and execute the different functions. So that's pretty much all we're going to need for function and classes. So I don't know if you have any questions, but if everything's all right, I have the code on the side, so I can go back to it if anyone needs anything. But for now, I'm going to go to the basics of PyGame, because I do want to spend more time on the actual game. So I'm just going to leave it up here for a couple of seconds. So basically what I'm gonna do now is go through the basics of PyGame. So the different things that you're gonna need when you set up any game you're gonna make or any program in PyGame, and the things that are gonna pretty much be there for any program you make in PyGame. All right. So I'll delete this for now, but if anyone needs anything, it's still there. Wait, how do we save this? Control S or files save as, and you name it anything you want, .py. And a little bit of advice: don't save it as the name of the library. For example, if you're using PyGame, don't name your file pygame.py because you're going to run into some errors. Like if you're using random, don't call it random.py. But yeah, you just save it and you add a .py at the end, and it will save it as a Python file. Okay. Can you paste the code here? I can't type. Oh, okay, yeah. I'll just copy paste it. Oops. Yeah. No problem. I'll just. There you go. That should be the code. I don't think there should be any. Yeah, it looks fine. All right, no problem. So yeah, if you need to go back over anything, don't hesitate to ask. All right, but let's go into PyGame. The first line you're going to need is import PyGame. So obviously, this will just get all of the built-in functions that are inside the PyGame module. So import PyGame is you're going to use this for any module you use if you're using random, which we are going to use. You can import random, and if you want to import multiple modules, you just import PyGame and random, and this will import the modules. All right. The next thing you want, the first line in pretty much, well, the second line in pretty much every PyGame program is pygame.init. So this simply initializes everything. So it reinitializes your game. It reinitializes everything. There is nothing that if I run this, there is nothing right now, but we do see that it is a PyGame file. You see the version of PyGame, and there's a link to the PyGame documentation or donation link, I guess. And yeah, so pygame.init, very important. And after that is when we're going to be starting to make our window. So creating the window that's going to pop up when you start the program. So first of all, what I like to do is to define two variables as the screen height and the screen length to define how big the window is going to be. So in our case, it's going to be a 300 pixel high by 600 pixels wide window. That's just the size that worked when I tried the game. So we're going to be doing that. And when, for example, I'm going to do SL for screen length. I'm going to set it to 600 and SH for screen height. and 300. These are not variable names that you have to use. You can call it whatever you want. You can do string_length, but I find SL to be easy because we are going to use these variables later in the code. So it's easy and it's very recognizable. Okay, and if there's a simple way, I don't know if you knew that, but you can do SL/SH is 600, 300, and you define both the variables with these different values. So it's a pretty cool way of defining variables, especially if they're linked like this. It's a very concise line. All right, next up, we're going to define our window object. So I'm going to call it win for window, and we're going to set it equal to pygame.display.set_mode. And then inside of this, we're going to do screen length, screen height. So I'm going to write, pretty often I'm going to write the line of code and then I'm going to explain it. So don't panic if you don't understand what I'm writing. I'm going to go back over it and ask questions if there are anything. So this simply, it's pretty self-explanatory, but it sets the mode of the display to a window with the dimensions screen length and screen height. And it's very important to have these double parentheses because the first ones, the outside ones, are the one for set mode, and inside is a pair of coordinates. So it needs to be in a tuple, so inside another pair of parentheses. All right, and next thing we want to do is to define our clock object. Now, the clock object is not a necessary object in PyGame, but it's a very useful thing to have because later on we can define the frames per second, and that'll make the game run at the same speed on every computer. If you don't define a clock object, the game will still work, but it will not run at a constant speed depending on the strength of the computer. So it's much more efficient to actually use the clock object. All right, and after this, now we simply need a loop, so a while loop, to run while the window is to be open. Because right now, if we run this, you can see that we have a window that pops up and closes immediately. So we do have a window. This does in fact create a window, but it closes immediately. So we do need a loop for the window to remain open. So for this, I'm going to define, put an extra space here. I am going to define a variable called run, and then say while run. So while run equals true. I forgot how do we run. Oh, Control B. It should work. Well, for Sublime Text, it's Control B. I don't know if you're using Sublime, but if you are, Control B should be the. You can also do project and think open project. Oh wait, no, that's not the project. I don't know, but Control B is it's the command to use. All right, and in this loop is what we're going to do during the game. So during the game, the loop is going to run, the window is going to remain open, and when we declare run to be false, that's when the window closes. All right, so the first thing you need to do in your loop is to have a for loop, an event get function. So for event in pygame.event.get, and I'll explain this just after I finish typing it. If event.type is pygame.quit, then run equals false. Okay, so all this is doing is when the window runs, so let's say I run this. We now have, we now have a Pygame window. It remains open because the loop is still running. But if we didn't have these lines of code, when we press this X, the window would not close. We actually need to tell Pygame that if the user presses this X, you need to close the window. So this is what this is doing. It's simply getting, if event pygame.quit is basically kicking this. So it's looking at all the events happening in this. And if the user is clicking on this, then run equals false, which means that it should quit the program. So it's doing this and it closes. All right. And it works without this, but outside of the loop, I always like to have a pygame.quit just to link back to the initialize, just so it initializes a new PyGame, and then it quits it at the end. It's just much neater if you need something afterwards or something. It's just a better way to write it. All right. Last few things that you'll need are the frames per second. So the reason why we have this clock object is to have this other function here, clock.tick, and then we'll define it as 30. So 30 frames per second. Basically, this loop runs 30 times every second. So it's the basic thing that people use in game development. 30 frames per second. You can do 60. You can do whatever you want. You can make games at 10 frames per second if you prefer, but it's 30 frames per second is the standard in game development. And you also need to have pygame.display.update. So what this line does is every time it loops, it updates the window. Without this, if something changed, like if somewhere in the loop something moves or something, the window won't actually open it. The object will have moved, like in the intelligence of the computer. It'll know that the object is not at this position anymore, but it moved, for example, 10 pixels to the right, but it doesn't update on the window. So we do need to update the window every loop. Finally, you need some kind of background. So you need to redraw the background every loop, because if something moves and you don't redraw a background over it, you'll still see the previous iteration of that object. And I'll show you this very quickly. So the way to have a background is simply to use this win, so the display, and you fill it with any color you want. The color is always in RGB. Hi, Panther. Oh, it's fine. Don't worry about it. If you don't know about functions and classes, I sent the code earlier in the channel, but we're just doing some PyGame basics. So you fill with a color, and the colors in PyGame are in RGB. RGB basically means you give 3 integer values. The first one being red, the second one being green, and the third one being blue. So the values go from the values go from 0 to 255. 255 being the max of that color. So for example, if we want a black background, we do 0, 0, 0. So that'll be black. If we want white, we do 255, 255. If we want red, so RGB, we do 255, 0, 0, and etc. So let's say we wanted gray. Gray being 125, 125, 125. So the middle, well, it's not like you can have any scale of gray, but this is like some basic gray. So if I run this, you'll see that we have a gray window. So it fills the window with gray on every frame. And let me just show you this very quickly. So let's draw a rectangle on the screen, just so I show you what this background actually does. So let's say I draw a rectangle. So pygame.draw.rect. This is the function to draw a rectangle onto the screen, and it takes 3 different 3 different parameters. The first one being the surface to draw on, in our case, the window. The second one being the color, so let's say red, 0, and the third one being x, y, width, and height value of the rectangle in order to know how to draw it. So let's just do 50, 0, 0, so x and y, and then 50, 50. So we have a square at 0, 0, and it goes 50 and 50. And one thing to note in PyGame is that this point here is 0, 0, and this would be 600 because that's our screen length, but this would be 300. So the y values actually go up as you go down on the screen. Now, this is a bit counterintuitive, but you will get used to it. But it's something that we need to keep in mind when we do some movement. So this would be the coordinate values 600 and 300. Okay, so now let's see what it does when we actually make the rectangle move. So instead of having 0, 0, let's have x and y and set their values to be 0 and 0. So this won't change anything for now, but let's say we did x plus equals 1, y plus equals 1. Okay, I'm not familiar with PyGame and the code isn't running. Like, do you see this message appear? Because you are using Sublime, so do you see this message appear in your console? Keep me posted on that. It should be working. If import PyGame does run this message, then you should be fine. Okay, so now if we do this and we run it, we can actually see that the rectangle is moving because we're adding 1 to the x and the y every frame, so it's moving. Okay, it has an issue. Did you try in the console? Did you pip install PyGame? Run this command in your console, and usually it should. I don't know if that's what you did. Okay, go in here. All right, let me just do it. So, cmd, and all right, and here if you do pip install PyGame, you'll see that requirement already satisfied. So it does say that I do have PyGame, and pip version has to be updated. And yeah, so but if you do this command, you should see this. If not, then it should download PyGame. I think usually you did that, but did you download PyGame? Try downloading PyGame from the website then. Maybe that's. I don't really remember. I downloaded it a while ago. Okay, but let's go back to this. Now, if we comment this out, so if we remove this line of actually drawing the background, we don't really have the illusion of the square moving anymore because we still have the previous iterations. So it does look pretty smooth, but let's say we did plus equals 5 and plus equals 5, and we did this. Now it doesn't look smooth at all. Whereas if we do draw the background, it looks as if the square is in fact moving. So that's why you want to draw a background every time. Follow the exact tutorial, but it's not running. That's weird. Could someone take care of that? Because I really don't have that much time, but usually on YouTube they have pretty good tutorials on how to download PyGame. There are a few tutorials. All right. So yeah, that's why you want to draw the background every frame. So let's get rid of this, and let's start the actual game. So, all right, let's start the actual game. So one thing you might notice, let me just run this again, is that it has a pretty boring name. It says PyGame window at the top here, and we might want to change that. Let's say we want to name our game. So you can name it whatever you want, and the way to do that is to actually do pygame.display.set_caption. And here you write a string. Whoops. You write a string. So for example, I'm going to write no internet because we are going to do the Google Dinosaur game when you have no internet, for those of you who didn't know. Oh, also make sure you downloaded the images because you will need those if you're coding along. So yeah, I don't know if I showed it, but the caption now says whatever you said in the caption. So let's say we write Fred's game, and there you go. So we have this nice caption. All right. Okay. So now what we want to do is I'm going to do this as explicitly as possible. So I'm going to maybe write more code than you usually would. For some people who know PyGame, they might know some quicker way to do it, but I'm going to try to make it as clear as possible for those of you who have never used PyGame. So I'm going to make a class, and I'm going to make a class for the dinosaur. So it's the first class we're going to make is the player. So it's an object, and the first function that we're going to write, as always, is the initializing function with self, and we don't need any parameters. And here we're going to define a bunch of variables. So first we have to define width and height, as well as x and y. So I have some values that I use, and I resized the images to match these values, just so we don't have to do a bunch of resizing inside of PyGame, although I'm going to show you how. But yeah, so just use these values. They're very hard-coded, but they work for the game, so that's what we're going to use. So the width is 35, the height is 50. Self.x, we're going to use 100, so it's going to be 100 pixels away from the left of the screen. And then self.y is going to be screen height minus 150. So let me just, nothing's going to appear, but let me just show you approximately where it's going to be. So screen length being 600, it's going to be at x 100, so 1/6 of the screen. And the y is going to be at the middle of the screen. So this is going to be the top left corner of the dinosaur, about here. So the rectangle should be something like this. That's why I did screen height minus 150, because remember, the y goes up as you go down. So if I take screen height and I subtract 150, I'll go up over the bottom of the screen. All right. I don't know if that was clear. Feel free to ask questions if you have any. All right. Now, these are the basic things. We're going to go back and add some more, but for now, that's all we need. We're going to define a draw function, again, using self. And for now, all we're going to do is represent the game with rectangles, and then we'll add the images later. So we're going to draw a rectangle, pygame.draw.rect. And again, we need to define the surface, so the window. We need the color. So let's do gray, 125, 125, 125. And let's actually change the background, because the background is going to be white. So 255, 255, 255. And over here, we also need to define x, y, width, and height, but we already have these. So we're only going to do self.x, self.y, self.width, and self.height. There you go. Now, if I run this, I do have the white background, but there's nothing, because I need to assign this dinosaur class to something. So let me create a player. So the player is going to be a dinosaur object. There you go. So now I have this dinosaur object set. I can draw it. So we can have player.draw. And now, if we run this, you'll see that we do have the rectangle. So this is going to be our dinosaur. All right, but it looks to be like kind of floating in midair. So I'm going to add a black rectangle at the bottom of the screen to act as the ground. This is just for aesthetics. You could do it without, but I find it nicer when there is a rectangle as the ground, just so the dinosaur doesn't look like it floats. So again, we're going to draw a rectangle, going to make it black, and coordinates are going to be 0, screen height minus 100, screen length, and 100. So basically, what I did is I did the coordinates being 0, screen height minus 100, and then the entire screen length and 100, so until the screen height. And now we have the dinosaur looks like it's on some kind of ground. So that's good. We already have that. Now, we need to find a way to detect when the player is jumping or crouching. Those are the two things, that the player can do in the game. So either jump or crouch. So what we're going to do is we're going to have a third function. Now, I could do all of this in the same one, but just to make everything clearer, I'm going to have a move function. So in this move function, I'm going to have this pygame.key.getPress. All right, so what this does, so I assigned the keys value to this. And this is basically going to, this function basically returns a list of Booleans, so true or false. And the list corresponds to every single key on the keyboard. And if the key is pressed, then it's true at the index of the key. And if not, then it's false. So we can use that. It's very useful for detecting if a player pressed up or down or spacebar, because up and spacebar are going to do the same thing in this game. So let's start by having the jumping covered. So we're going to do if keys, and this is how you're going to write it, pygame.k_up. So this basically tests. So if I did this, it would be true when I press the up key. So when I press the up key, whatever code is inside this if statement would run. But what I need to do here is actually have another variable here, which will be self.jumping, because set to false, because if you're already jumping, you can't jump more. Like you can't jump while you're in the jumping animation. So we need to test if you press up and you're not self.jumping. So basically, if you're jumping, then this can never run. But if you're not, and you press up, then you'll jump. So what we're going to do is say self.jumping equals true. So now we have this. So we have this line, which basically just detects if we pressed up and we're not jumping. So ready, that's start. But now we need to do the logic behind the actual jump. So now we have another if statement saying if self.jumping. So if you're jumping, this is what happens. And in order to have a clean jump, so we could just make him go up and then down, but we want some kind of parabola to make him jump kind of smoothly, go faster, then slow, and then fast again when he lands. So what we're going to do is I'm going to have a jump increment and set it to 0. And this is going to be very useful in the jump animation. So let me explain this when I write it. So basically what we're going to do is we're going to do if self.jumpInc is smaller or equal than 20. Finished fixing the bug, but I'm very behind now. Can you copy the code again and paste it here? Yeah, sure, no problem. I'll just, wait, let me just finish this jump and then I'll copy paste it. Is that fine? Just so I don't copy paste like half a finished code. All right, great. So we're going to use jump_inc while it's smaller or equal than 20. And we're going to say self.y minus equals, and then 10 minus self.jumpInc. So this is some logic that you can use pretty well. So basically, jump_inc starts at 0. And of course, we need to increment jump_inc as it is an increment. So jump_inc starts at 0. So at the beginning, self.y minus equals 10 minus 0. So self.y minus equals 10. So we'll go up by 10. And then jump_inc goes up by 1, so it's minus equals 9. So up by 10, up by 9, up by 8, 7, 6, 5, 4, 3, 2, 1, 0. And then when jump_inc is 11, then all of a sudden this value is going to be negative. So self.y plus equals 1. So when it reaches the top, it's going to go plus 1, plus 2, plus 3, plus 4, and back to plus 10, and go back to the original position. So that's the logic that we're using for the jump. And then we're simply going to have an else statement. So when jump_inc has finished the entire loop, so when it finished 20, when it's at 21, simply going to say self.jumpInc is back to 0, and self.jumping, so the jump is finished. So jumping equals false. All right, so let me just copy this. Yeah, just a sec. Go. Should be fine. And there you go. The code might not look great on the Discord, but if you paste it, it should be fine. All right. So now let's run this and see how it works. Well, of course, I can't jump because I defined this new function move, but nowhere do I say player.move. So nowhere do I actually call the function. So player.move, I need to call this. And now if I press up, you can see that the dinosaur kind of jumping, but it's not jumping very high. It's kind of like half jumping. So what we're going to do is we're simply going to multiply these values by 2. So it's a very simple solution. Now, if we jump, it's a much better jump, some nicer curve, and it works great. So that's going to be our jump. That's actually, we're done with the jump. Now let's just add if you press space as well. So let's just put this in parentheses to make it a little bit clearer. So if keys.pygame up or keys pygame.k underscore space. Space. All right. So now, basically, it'll check if you press up or space, and if you're not already self.jumping, then you can jump. So if right now I'm holding up, and you can see that I'm not jumping higher because it's waiting until I finish the previous jump to actually jump again. If I press space, it does the same thing. So that's our jump. Now what we need to do is do the crouching. So we're basically going to do another variable here, so self.crouching, just to make sure that we're not, jumping out of crouch, which would look weird. So we'll just do and not self.crouching, just so that you can't jump while you're crouching. It's not necessary. You could do it so that you can, but I just find it, cleaner without. So now we're just going to use another if statement. So I'm going to do if, and then again, we need keys pygame underscore down this time. So when you're crouching, you press down, and not self.jumping. Now, of course, if you're jumping, you can't crouch because that would look very weird. But you can't crouch if you're already crouching, because in the game, if you hold down, then you're still crouching. There's no longer animation. So if you're pressing down and you're not jumping, then self.crouching will be true. And we can change the actual rectangle, like the values of this, because the rectangle will now be horizontal instead of vertical. So what we're going to do is we're going to say self.w equals 50, self.h equals 25, self.y is equal to screen height minus 125. And trust me on these values, they're just the values that look better and that work with the images. And the x doesn't need to change. The x remains the same. And we need an elif here, because this checks if you're pressing down and you're not jumping. But what if you're not pressing down, but you're not jumping? So what if you stop pressing down? So elif not self.jumping. So while you're not jumping, we're just gonna make sure that crouching is false, just so you don't stay crouching, and self.y is back to the original values. So you just put the rectangle back as it was. Self.w is 35 and self.h is 50. And I think that's pretty much it for the crouch. Don't hesitate to ask if you have any questions, but I think if we run this now, oh, there's an error. If he's, whoops, pygame.k underscore down, my bad, and there you go. So now we can jump and we can crouch, there you go. And it does look weird with the rectangle, but with the image, it'll look fine. So we can see that I'm crouching, I can't jump while I'm crouching, but if I stop crouching, I can jump. So it's working great. So we actually pretty much finished the dinosaur. Now what we're going to do is we're going to add our first obstacle. So the obstacle that I really want to do is the cactus. If we have time, I can do the birds as well. If we don't, then I can just send the code that I have with the birds, because in the game you have some birds flying at various heights. But right now let's just do the cacti. So let's do another class Cactus Object. So again, it's going to be very similar to the player. So what we defined with the player, we're going to do what we're going to do in the game. You have either a big cactus or smaller ones. So what I'm going to do is, in our simpler version of the game, it's either going to be one large cactus or four half-sized cacti aligned one next to the other. And this is where we're going to use random, because we want to randomly choose between a big cactus or 4 small cacti. So a simple way to do this is to use the randint function of random. So it selects a random integer in the range you give it. So let's just say 1, 2. So it selects either 1 or 2. And if this returns 1, so pretty much 50% of the time, but not necessarily, then it's going to be a big cactus. So the width will be 25, the height will be 50, and we will just add another variable called big, just so we can use it later. So if it's big, then it has this variable called big equals to true. And then if this was false, so if this returns 2 instead of 1, then the cacti are smaller. So self.w is going to be 48 because it's going to be 4 times 12. But as right now we have rectangles, we're just going to do width of 48. Self.h is 25. Self.big is false. All right, but we do need y and x, which are going to be the same. So self.y is screen height minus 100. Oops, 100 minus self.h, so that it depends on whether the height is 25 or 50, but it is on the same ground level per se. And then self.x is screen length. So why I'm setting the x to screen length, let me show this by running it. So you won't see any, oops, did I do? Self is not defined. Whoa. Oh, right, whoops. I need to define, sorry about that, a bit of a brain freeze. There you go. So now if I run this, shouldn't be an error. All right. So the reason why I'm defining self.x equal to screen length, so over here, is so that the cacti appear to be coming from this side. And when we're going to make the cacti move, they're going to come into the screen. And it's going to look like they've always been farther here, but they're just going to create themselves here and move this way. So fairly simple stuff. Now, again, we need a draw function. Oops. Draw self. Okay, so now we need to draw a rectangle. So pygame.draw.rect window. So again, the same thing. Let's make it black. And then self.x, self.y, self.w, self.h. And do tell me if I'm going too fast. But the reason why I did this pretty quickly is because it's the exact same thing as we did with the player. I only changed the color of the rectangle. All right, and now we're not going to define each and every cactus individually. We're going to do, as I said earlier, we're going to have an enemies list. And in the enemies list, we're actually going to have all of the different cacti go in there. And then we can just call the functions for every cactus. So now in our loop, what we're going to do over here, we're going to do for enemy in enemies. So for every item that's in this list, we have to move the x of every enemy down. So it needs to move this way, so towards the left. So we're going to do enemy.x minus equals 5. Just so it moves at a decent speed. And we also need to draw the enemy. And yeah, so let's start with this and see how that goes. Well, there's nothing, right? Because we're not creating, nowhere are we creating a cactus object. So to do that, because we don't want to create one on every single loop, we're going to use an increment. So inc is equal to 0. Again, increments are your best friend. So let's have another part of the code here. Increment plus equals 1. So it adds 1 every loop. And then if the increment is 100, so once it loops 100 times, then enemies.append a cactus. All right, and we set the increment vac to 0. So every 100 loops, a cactus object will be created. Could you paste the code again so I can see if I'm doing everything right? Yes, sure, no problem. So you can see, let me do this. You can jump. Right now there is no collision, but it is creating these bigger and these smaller cacti. So this is really good. We have made a lot of progress. We now have obstacle moving towards, well, giving the illusion of moving towards the left at a decent speed. And our dinosaur object can jump and crouch. So that's great. So let me just, again, oops, time. There you go. Cannot be delivered. Sorry, I don't know why this Python cannot be. Okay, wait, that's weird. It's not letting me send the code. I don't know if you guys can see it in the chat or not, but I'll just send it. Okay, wait, let me. If it's longer, okay, yeah. Let me. Okay, wait, I'll just copy this part before the loop and then copy the loop itself. Yeah, that's what I'm gonna do. There you go. And now I'll just copy the loop. And there you go. All right. So that's the full code that we have for now, which is already pretty good. So now there are a few things that we want to do. First of all, we want to detect collision. So we want to check if the player hits a cactus. And if the player does, then for now, we're just going to make the game close. All right, so for that, what we're going to do is we're actually going to define another function for the cactus. We could do it in the player, we could do it anywhere, but I'm just going to define it here. So we're just going to use a built-in function in PyGame. So we're going to have an if statement. So if, and we're going to make a rectangle out of well, the cactus in question. So with the self dot width and self dot height, we're going to make a rectangle out of this. So basically, the rectangle that we're drawing, we're just going to make a rectangle out of it in the PyGame logic, and we're going to check dot collide rect. We're going to check if it's colliding. So we're going to check if this rectangle is inside this other rectangle. And this other rectangle is simply going to be the player's coordinates in the player's rectangle, not self player.y, player.w, and player.height. There you go. And if it's true, then we simply return true. And if not, then we return false. So this function will either be true or false. So this is a good way of doing it, because now if we go here, we can simply do if enemy.hit. So if this is true, then we just set run to false. And now if we run this code again, just take a sip of water, and I'm going to let myself crash into this cactus. Boom, the game closes. All right, so we do have some collision detection now with this very useful collide rect. Another thing that's useful to know is that if it was contains instead of collide rect, then it would check if this rectangle is fully inside of this one, which is not what we want, but it could be useful in some other cases. But right now, we just want to check if it collides. All right, so that's really good. Now we want to find a way to make the game go faster and faster, because that's what happens in the actual game, right? We want the difficulty to go up. So we're going to have another variable called game speed, set it equal to 1. So it starts at 1, so the basic game speed, and we're going to use it at various different places. First of all, we're going to make the increment multiplied by game speed, because then enemies are going to spawn quicker, closer one to the other. And here we actually don't want to set it equals to we don't want to set it equal to 100, because let's say this is 1.1, then it won't be exactly equal to 100. So let's just make it so it's larger or equal to 100, just so in case it turns into decimals, or I don't know, for some reason it goes from 99.2 to 100.1. We don't want it to like stop spawning. All right, and we actually want to make the game speed go faster, so game speed plus equals 0.1. So every time we spawn a new enemy, the game speed goes up by 0.1. But here the problem is, enemies are simply going to spawn closer and closer, but they're not going to be moving faster. So we actually need to make them move according to the game speed. So here we're going to multiply it by game speed also. So we're using the game speed at 2 places. First of all, we spawn enemy closer to one another, but we also make the enemies move faster. So if I run this, at the beginning, it doesn't change anything. Let me just try to survive. Your guy cannot jump. That's weird. Check the jump function, or the moving function. Can it crouch? First of all, if he's able to crouch, then it's weird that he can't jump. Are you pressing? Okay, well, first of all, we can see that the enemies are moving faster. They're spawning closer to one another. So that's working well. The guy cannot jump. That's weird. If you copied, also doesn't spawn. Okay, well, did you have player.move here? And if cacti aren't spawning, then are you making sure to append the object to the list? I will make the code available afterwards, so you can check what didn't have correctly. I copied the code, so okay, that's very weird. If you copied the code, then maybe there was some formatting mistake somewhere, like the Discord. Maybe you put can't jump or display. Did you also copy the code? No. Okay, well, that's very weird. Okay, if the dinosaur can't jump, he can't jump at all. So do you have maybe you don't have this right? The keys.get_pressed, but it's not giving an error. So it's actually displaying the game, but it's just that he can't jump and the cacti aren't spawning. Are you okay? Wait. I know. Did you do PyGame.display.update at the end? Because if you're not updating the display, oh, it works. Okay, great. Maybe it's an error because you haven't saved your program. I don't know. But okay, please just keep me posted if there's anything that's wrong. But I just want to get a few things covered. We also want a score. So we want a score variable to set 0. And we want to have an increment. So we don't want to add the score every time. We could, but I don't want to add the score every loop because that would make it go a little fast. So I'm just going to have an increment here. Put the score right here. And I'll say if score inc, so the increment, I think that's, yeah, score inc, is smaller or equal to 5, then I'm simply going to make the score inc plus equals 1. And here I want to multiply by game speed. So I want the score to increase with the speed of the game. And if it is higher than 5, then we set the score inc back to 0. Oops. And we score plus equals 1. So now we should have something. So let's just print the score. This is not the way to go, but we're not going to keep it like this, but just so we can see. So we can see that the score is going up, should be going up faster and faster. And yeah, so the score is going up. That's working great. That's good. And we want the score to appear on the screen, so as a text. So how do we do that? It's fairly simple. We need to create a font, which will be able to equal to pygame.font.sys font. And then here, there's going to be a great debate on the font to use. I'm just going to use Comic Sans because it's just a very basic font. And here we're going to have the size, so 50. All right. Then we're going to have our text. The text is going to be font.render. And then we need to render a string. So let's render the string of score. Let's make sure we need 1 so that the text does appear, and then 0, 0, 0 for the color. Because we have a white background, I'm going to draw it with in black. And this is just going to make it look nicer. And we need to win.blit. So blit is a function that will make an object appear on the window. So win being the window or surface.blit, and here we just blit the text. And where are we going to blit it? We're going to blit it at the screen length minus, and here's a very useful thing, .get_width. So what this does is it finds the width of the text object. And so the text object will always be to the left of the screen length, even if like the score goes into the millions or something for some reason. And let's add a margin of 10 pixels and then have an upwards margin of 10 pixels. And I'm just going to run this so you can see. But over here, we have the score. Oh, I'm still printing it. I'll remove that. But you can see, oh, wait, I didn't show you. But wait, first of all, let me remove the score here. I don't want to print it. But when it becomes 10, it actually moves to the left. It didn't move to the right. Even though technically the X, like every object, start with the top left. That's because we subtract the width of the object so that it remains on the screen. So let me die. Oh, I died at 98. That's sad. And yeah. So that's the score. We now have the score being like appearing on the screen, which is good. What else did I want to do? Okay, let's add the images now. Okay, this is the interesting part. Let's start with the dinosaur because it is more complicated. And I don't know, there's no logic to that. Let's just start with the dinosaur. So okay, let's see what I have in my directory containing the images. So here you go. I have here all right, so I have all of these images, and these are all the different things that I have for the workshop. But as you can see, I have these two walking images. So this is walk 1, this is walk 2. And what we want to do is just alternate between the two to give the illusion of the dinosaur running. All right, and the way to do that is by creating a list containing these two. So let's just create a list called run images or image, img, whatever, and making a list. And here we can use pygame.image.load, which will get an image that's in the same directory as your code, which is why you need to make sure that the images are directly in the same folder as your code, not like in a folder next to the code. You can't have a folder called images inside your folder. I don't know if that makes sense, but you have to make sure that they're in the same directory. And here we load walk1.png. And let me just copy this because it's walk 2. And we need also walk2.png. All right. And now what we're going to do is we're just going to have them all, right? We're just going to make sure we have them all. Crouch images is pretty much the same thing but it's crouch 1 and crouch 2. Here crouch 1 and crouch 2, and we need self.jump image. And for the jumping, we only have one, because the dinosaur doesn't move while he's jumping. So I simply have to do pygame.image.load jump.png. There you go. Now we have all the images. And I'm actually going to have the images in the draw function because it makes sense. So let's start with the jumping one because it's very simple. We only have one image. What we're going to do, we're going to say if self.jumping, we're going to blit the image. So it's fairly simple. We just win.blit on the jump image. And we just give x and y, so self.x, self.y. And now, if I run the code, still have this rectangle, but if we jump, you can see that the dinosaur does appear, and it looks very weird because there's still the rectangle. But let's say I remove this rectangle for just a second. Now we won't have a dinosaur right now, but if I jump, you can see it looks kind of normal. The dinosaur is jumping. That's good. Now let's do the same for crouching and for just running. So we'll do an elif self.crouching. So that's either crouching. You need to alternate between two images. So what we're going to do is, again, we're going to use an increment. So we're going to have crouch increment. The crouch increment is going to start at 0. Now, let's think about this for a second. We need to alternate between the 0th index of this list and the first index of this list. So what we're going to do is we're going to lib.blit self.crouch image. And here we need an index. And what we're going to do is we're simply going to have self.crouch increment. And we need to integer divide it. And I'll say by 5, just because that's the number that I found that was good. And I'll show you how it works afterwards. But let's just have self.x and self.y. And here, what we want to do is simply to say if self.crouch inc is equal to 9. So before it reaches 10, because if crouch inc is 10, then 10 integer divided by 5. And this double division is integer division. So it basically, if it's for example 5 divided by 2, it gives 2.5, but it will find 2 because it'll go to the lowest integer, to the closest lower integer. So if it's 10, this will give 2, and it'll be out of range, right? Because crouch image at index 2, there's nothing, so that'll give an error. So we want to stop at 9, and we're going to set it back self.crouch. Crouch inc. We're going to set it equals to -1, simply because right after, we're going to make sure that the increment goes up by 1. So basically, we're just going to go up by 1, but if it reaches 9, we set it equals to -1, and then it'll go +1, so it'll go back to 0. And 0 integer divided by 5 will give 0, so the 0th index will give the first image. All right, so let's try this now. Oh wait, let me just remove the rectangle, just because it looks a lot better without it. So when we're running, we don't see anything. If we jump, there's this, and if we're crouching, you can actually see that it's alternating between the two images. So this looks really good. It's going really well. Now, let's finally have, if you're not jumping or crouching, then you're just running. And for the running, it's exactly the same logic as the crouching. Except instead of crouch, we're just going to have run. Run image, run inc, run inc, run inc. And I'm pressing Control if you don't know. Forgot an H here. And you can just select multiple places at the same time. It's very cool. And so now, I don't have the rectangle, but you should see, whoops, dinosaur has no attribute run inc. Oh yeah, I forgot to define self.run inc is 0. And if he's running, he just runs like this, if he's jumping, and if he's crouching. So the dinosaur is now fully done. We now have a full-fledged dinosaur That's running, walking, and running, crouching, and jumping. So, okay, that's really good progress. Now all we need to do is have an image for the cacti, and we'll pretty much have finished the actual game. One other thing that I want to do is have some kind of end screen. And I don't think we'll have time for the birds, but I don't know, maybe with some miracle. Okay, so for the cactus, over here, just going to have another value, self.image, because there's only one image for the cactus, is pygame.image.load, and we're going to load cactus.png. I wasn't very original with the names, but yeah, that's the name of the image that we're going to use. And the big cactus and the smaller ones are the same image. It's just that we're going to resize it. And the way we're going to do this is if it's a small cactus, we're simply going to define self.image to be pygame.transform.scale. So we're just going to resize the image. So self.image. So he's going to take this image and resize it to be let's see, self.w divided by 4 divided by, or just 12 actually. It's just hard coded. So we want 4 of them here. So let's just have 12 and self.h. So it's going to resize the image of this cactus to 12 and 25 pixels. All right. And now in the draw function, let's remove this rectangle again. I'm just going to comment it out in case you want to see the rectangles again, maybe by nostalgia or something. And if self.big, now this is where the big comes in handy, because if it's big, we only want to split one image. So self.image, and then self.x, self.y. Very simple. But if it's the smaller ones, we want 4 of them. So what we're going to do is we want this again, right? Because the self.image is going to be this one. But we want it 4 times. So 1, 2, 3, 4. And we need to move the x. So plus 12, plus 24, and plus 36. And all this is going to do is have 4 cacti 12 pixels away. So let's just see when I run it. And you'll see exactly what I mean. So we have the nice dinosaur jumping, and oh, what is this? Argument 2 must be 2 items sequence, not integer. Oh, I think I'm just missing some parentheses. Oops. Here you go. Check. Yeah, that's it. So this should work now. There you go. This is a big cactus. You can jump over it. And there you go. We have 4 smaller ones, 12 pixels apart. And this looks really good. See, we changed our rectangles and we made them actual images. So now the game looks good. Now, one thing that I want to do is actually have an end loop. So let's have end equals true as well. And before the pygame.quit here, we're going to have another while loop. So while end. So over here, we need end to be false as well. This is when we close the game forcibly with the X. But when we lose the game, so when an enemy hits us, then run is false and it goes into this end loop. So while end, I'm just going to make a very simple end screen. So I'm just going to have win.fill 0, 0, 0. And again, have this little piece of code for event in PyGame, that event that gets, blah, blah, blah. Run is false, I don't need to have that. And is false, so it will break out of this loop, just so we can press X. And what we're going to have is we're going to have some more text. So basically that's all there's going to be. It's going to be text. So font, again, is going to be font Comic Sans 50. Instead of text, we're going to have final score. Final score is going to be your score, and then plus the string of the score. And And instead of 0, 0, 0, it's going to be white because over here our background is actually already black. And then we also want a message to say font.render to say click anywhere to exit, sort of thing. Click anywhere, exit. And this is a nice way for me to show you how to detect a mouse click. 255, 255, 255. And now let's say we want this text to be centered, right? Just so it looks better. So we're going to blit the text, and we're actually not going to blit text, we're going to blit final score. And instead of this, what we're actually going to do is we're going to do the screen length divided by 2, so that's the center, minus the text width divided by 2. So what this does is it's just going to have it centered. And then we don't need 10, we're just going to do screen height divided by 4. So it's like somewhere top middle, approximately. It's not very precise. You could have it much more precise than that. But I'm just going to have the same thing here. And over here, it's not text.getWidth. We have to be careful. Final score.getWidth. And then here, same thing, minus exit game.get underscore width divided by 2. And screen height, let me check where I had it. Okay, times 2/3. Just so it's somewhere, somewhere at the bottom. And now we need to detect the mouse click. So this is a very simple, it's 2 lines. If pygame.mouse.getPressed. And this function is actually a list of 3 values, true and false. It's a list. So the first item in the list is left click. Second item in the list is, I believe, right click. And the third item in the list is if you click on the scrolling button. But right now we only need the first one because we want to check if there's a left click. So if this is true, then end equals false. And I believe we are done. And you can jump, crouch, we have the cacti. And if I run into them, oh, what did I do wrong? Invalid, oh, oops, this needs to be between a second pair of parentheses because it is a tuple again. Just like coordinates, RGB are between parentheses. So if I run into this again, now see, this is a classic mistake. I forgot to update at the end of this loop. So it just stayed at the previous screen, which could be useful, if you wanted to have like a freeze frame of the dead screen or something. But what we want is some kind of end screen. So there you go. It says what your score was, and it says click anywhere to exit. And if I click, it closes. Fantastic. So yeah, that's pretty much what I wanted to do. I mean, I could show you, because I do have a finished version of the code with the bird. So I could show you that. Let me just grab it and bring it here. So it's the exact same code. And another interesting thing that I did that I wanted to show you guys, that I'm not actually going to code in front of you, but it's fairly simple. It's that these rectangles are the rectangles that we have, but these are a second rectangle. And what these are, and they have this special extra parameter here, that's 1. And that means you don't actually fill the rectangle. And what these are, if I actually put this there, and I run this, you can see it's the same game, but I have the hitbox. So this is an interesting addition. If I wanted it on everything, I'll just have it, where is it, the cactus, and I'd have it here. And then if I run the game, you have this red rectangle around, and this red rectangle around the cacti, and if they collide, I actually missed, I meant to make it cut, okay. If they collide like this, then boom. So this is just a very visual way to show the hitboxes. And one other thing that I wanted to show you, I think we pretty much did all of this. But another thing is that I have this bird object, okay, that I did want to show you. So basically, this object is very similar to the other ones, with a width, a height, a y. The y is the interesting part, though, because there is a random part to it. So what I did is, this is basically the y coordinate of the ground, and then I subtracted the height plus 10, just so there is some margin between the ground and the bird, and then I multiplied it by a random value between 1 and 3. And let me show you what this is. And basically, I did the same thing with the images, just so they alternate between two images. And I have the hit function. Oh, wait, and first, let me just show you. When I spawn the enemies, where is it? Here. So if the increment is larger or equals to 100, then I can randomly either spawn a bird or a cactus. But I only spawn a bird if, well, I have the same logic here, if random.randint12 is 1, but also if my score is larger or equal than 100. So that means that the bird enemy only appears if your score is larger than 100. That's a good way to have the difficulty go up. And also, oh yeah, one last thing that I wanted to show you guys that I haven't actually done because I just simply forgot, is these two lines. Basically, when you get farther into the game, this list of enemies, you're adding a bunch of enemies to it, and it becomes like very long for no reason, because the enemies are still going into like the hundreds of negatives in the x, which is like far off the window. So what I did here is simply said that if the x plus the width of the enemy is 0, then I just remove the enemy from the list. So if it's basically disappeared off the screen to the left, then I simply remove it from the list, so that the list is way less packed, and the computer doesn't have to think about all these enemies. So basically, the only enemies that are in the enemies list are the ones that are on the screen. So that's a good way of making the code better. Okay, now let me just show you the birds. So I'm just going to try to get to 100 points here. So yeah, feel free to ask any questions if you have any. I'll just show you. Let me just get to 100, and there you go. So now birds should randomly spawn. There you go. So you have this bird at the middle. You can see that it was kind of like flying animation. There are 3 different heights. So this is the highest height. You can't jump above it, but you have to just, not do anything. You can jump or crouch above the middle one. And then there's the lower one right there that is on the ground and you need to jump over. So that's what the 3 random heights do. Just have it randomly set between higher, middle, or lower. And there you go. So that's the game that I have. If I crash into a bird, then I have this end screen. I click anywhere, and it closes the game. So I think that pretty much concludes the workshop. If anyone has any questions, please feel free to ask. If you have, can you paste the finals code? Yes, I could. Wait. I'll paste this code with the birds, just so you can check those out too. So let me just have this. Just see. I think I'm also going to send the actual code file, but is over. Oh, okay. So it's too many characters. Actually, let me see if I can. I'll just whoops. I'll just learn talking. So upload, and there you go. So I think you should be fine with that. If you run this code, and you should see it. There it is. Usually you should be fine. I think it's the exact same code. This is the version that I made myself with the birds. So yeah, I think that's pretty much it. So thanks everyone for being here. And yeah, that's pretty much the game development with Python workshop. If you have any questions, I will stay in the room for an extra few minutes. And yeah, so thank you very much. Give me just a second. I'm going to go get some water. And all right. So if anyone has any questions, feel free to unmute or to just type them in the workshop channel. But that's pretty much the workshop. So thank you very much to everyone for being there. I hope you had fun coding the game. And if you actually do maybe add something to the game, feel free to send them in the share your creation channel, or ask any other questions in the coding questions channel. And I am pretty much always active. I can always answer your questions. If you need something more precise, we can always hop in some call. And yeah, so thank you all. And that's the game development workshop.